Hey, good morning, everybody. How are you doing? Dr. Heldman here, fresh back from a trip to San Antonio to see my son and his beautiful girlfriend. And we're going to talk some more about MPI and MPI programming. In this video, this is number 5 of the cluster node videos, cluster computing videos. We're going to write some more in-depth C programs. So let's get started. It should be cool and useful and very fun and really good knowledge. Well, so the first thing we're going to do is we're going to modify hello mpi.c to give it a little bit of extra strength. So let's go back in and revisit that. We'll go through the code a little bit as well. So I'm going to nano hello underscore mpi.c. Now it's got to end in C because we're telling the computer it's a C program. When we go back through here, we have two include directives, mpi.h and stdio.h, standard.io.h. We've got the main function here. I want to take a little bit of time here just to explain what this thing is doing here. I talked about this in an earlier movie, but the concept with C and C++ programs like that, when you have a function, the function may need to return some data back to the calling program. And in this case, with main, it's almost always going to be an int. And if it is a successful program, we return 0, which means everything's good, it ran fine. Else, we return some other number. Now, what that means, if you're calling the program and it's running, it means that it will error out, and the compiler will display an error to you. And what programmers do is they get into the business of trapping these errors and doing something about it. For example, if a user wanted to run a program but had to supply a file in which to run the program and did not, and the computer couldn't find the file, that would error out. The programmer's responsibility is to trap that and do something about it. In this case, it would be display to the user the message, hey, I need a file in order to go ahead and keep processing. Now we've got the init function, which is always going to be there, and it's getting an argc, argument C, and argument V. We're declaring two variables, world size and world rank. This function here is always going to be there. It's going to be com size. We pass in com world, com rank. We pass world rank into com world. We pass world size into com world, so that the MPI cluster node environment knows the ranking of the nodes as well as how many nodes that we have. And then we have this printf statement here. So let's go ahead and modify this a bit. I'm going to stare a little bit at the computer so that you can see what, so I can see what I'm doing. I can see my notes. And so let's just keep this printf, but right after this world rank line here, I keep wanting to click an insertion point because I keep thinking I'm dealing with Microsoft Word or Visual Studio or PyCharm or something like that. And I'm not. I'm dealing with a standard text editor. What we're going to do is we're going to get the processor name. So I'm going to declare this as a char. I want to stop here and say C and C++ programs, I think Java is this way as well. You have to tell it first what the data type is that it's supposed to get. And then it'll use that as that data type. So in this case, we're saying we want to create a data variable type that is a char. It's a single character, and we're going to call this processor name, processor underscore name, and I'm going to pass in an array here. And the array is going to be MPI max processor name, like so. And so it's going to be able to grab all of the processor names and pop them into this array, and we can parse that as we're going along. Also, we're going to declare another variable called, it's going to be of type integer, and we're going to say that the name is going to be the length here. Now, you must put in a semicolon at the end of every C statement. If you don't, the compiler is just going to barf, and you're going to have to go in and fix it. I will tell you that the GCC compiler is pretty good about pointing out where the errors are at. So back in the day, if you were programming, it might be difficult to find out where the heck the thing was going wrong at. But today, the compilers are pretty good about indicating the location of where there's a problem. we're going to declare an integer called name length, and now we're going to do a new function called getProcessor. So it's going to be MPI, this is an MPI function, proper name is get, and then we're going to say processor name. So this is an MPI function, and it's going to get two things. I'll close this off with a semicolon so I don't forget. I will also put in a comment here, get node name. All right, so we're good to go. Now what we do is we pass in, we're going to go ahead and pass in the processor name, which we declared up here. This is processor name right here. So we're going to pass in the processor name because this function, getProcessor name, needs that. But also we're going to pass in something else. We're going to pass in the name length. So we're going to dereference a pointer to name length. And did I put a comment in there? I did. Okay, so we've got that now. Now what we're going to do is change out this statement here just a little bit where we have the printf statement here. And what it's going to look like is this. So we say hello from processor, but in this case we're going to put in %s like that. %s, which means string. And then we will put a comma rank %d. Oh, I've already got that. Out of %d. So we just modified that. And then on the end of this, we'll put in processors. And I'll put a period there instead of an exclamation point and widen this out just a little bit so it's a little bit easier to see. So now we say hello from processor, %s, rank %d out of %d. Now we know that this %d is a decimal, and we're getting it out of world rank here. And we know that this %d is world size because we wrote this code before, but we don't have anything to hold this here. So let's go ahead and put that in there, and the variable that we're looking for is going to be processor name. So I'll type in processor name. I'm going to have to widen this out again, huh? Like so, and let me recenter it like that. I'll center the screen. There you go. Okay. So we say printf hello from processor %s. Now this %s is going to go in and it's saying I'm going to get a string and it's going to get processor name. Well, it's going to get it out of this array here. Why is that an array and what is an array? So when you have square brackets here like this, let's see if I can highlight those. These square brackets here indicate that we're dealing with an array. And what an array is it's just, you can think of it as an apartment house where we have several apartments that contain data. Now with an array, the apartments all have to contain the same type of data. So in this case, this array, MPI max processor name, has to contain char type data. And we're just going to iterate right through this array and get each one of the members. Why do we need that? Well, because if you're thinking about a cluster computing environment, we might have hundreds or even thousands of these cluster nodes, these compute nodes that are out there. And so we want to get each one, and they're all going to be populated into an array that we can query in order to get information out of it. And finally, we have MPI finalize. I'll put in a comment here. I don't really need to, but there's a comment in my codes here. So what we're doing here is we're cleaning up the MPI environment. Now that's not a big, huge change, but if you look at it, you can see that we've done a little bit of interesting work here. And we've added one more function here called getProcessor_name. So this is really extensive. There's a lot to know about MPI. We're using OpenMPI. We're not using mpi.h. These are both very, very popular. This is called high performance computing, HPC, and these are very popular in the world of high performance computing. Finally, we want to point out that this \n means skip a line. That's a new line escape sequences. There are numerous escape sequences, the most popular of which are \n, which stands for new line, \t, which stands for a tab, so it's going to indent 5 spaces. All right, so what we do now is we save this, Control-O and Enter, and Control-X. Now we'll go ahead and recompile this. So this thing has already been compiled. We can see because we have the green hello MPI out here. So it's already been compiled once. If we tried to run it right now without recompiling this code, we would get the old code, we wouldn't get the new. So we want to see the new code, so we have to recompile it. So we say mpi.cc, mpi code compiler, or compute compiler, whatever it is. Then we say that we're going to pass in hello mpi.c, and we're going to output to hello underscore mpi. Now, if I wanted to keep this way, so that I had hello mpi, this is the old one, and I wanted to go with the new one, I could do hello mpi2, or I could reverse it and say mpi hello, or whatever. It wouldn't matter. So let's go ahead and hit enter, and there we go. We do an ls. Now it doesn't look like anything changed here, but let's go ahead and do an ls tac al, and we'll see, where is it at? Hello mpi now is March 4th, and it's a little bit bigger now. So you can tell that it definitely has recompiled. I'll clear the screen, and we're going to run this thing. So we say mpi run. We have to tell it that we have a host file out there. The host file simply tells the computer how many nodes that there are in the cluster environment. And we're going to point it to / mp, oh, it's not mpi host, it is mpi host. mpi tac hosts is the name of our host file. And then we're going to do the number of processes that we want it to execute is 6 cycles. And then we'll do a /, and this is hello underscore mpi, like so. That's how you run the thing. Let's see what it brings back to us. Now it's out there, it's querying the nodes, and it's getting the information out of here. And you can see now that it's telling you what it's getting. So it's getting master node here, rank 1 out of 6 processors, master node rank 0 out of 6 processors, from processor 2 out of 6, 4 out of 6, 3 out of 6, 5 out of 6. So all we're doing is we're saying, hey, return back to me. What I'm trying to do to validate here is, are all of the players alive and well, and are they doing what we want them to do? Now this isn't the greatest here. We might want to consider coming up with a way to rename these so we get better names out of these, and that's certainly doable. And I'll show that in a different movie where we do something where we can get the names out of here as well. But that's the idea. What we're doing is we're actually putting this thing to work now. So that's pretty cool. I like that a lot, and I will create another movie where I show you how to actually name these processors. The reason we would want to know these names rather than these numbers is because we would want to be able to tell when one processor isn't playing in the sandbox, if you know what I'm talking about, like maybe it powered down or it's not doing something correctly, whatever. Okay, well, it was bugging me, and so I decided to pause the movie and troubleshoot why I'm not getting the other host names back. Let me show you some of the steps you would go through. First of all, you would go out to each node and you would run the host name command. So host name should be set properly, and here it is, it's master node. That looks good. Let me go out to compute node 1, and you can see that I ran host name here. It shows fine. And here's compute node 2, and it shows fine. Another thing to make sure of when you're troubleshooting this is that you cat etsy hosts. They all look great. This is super good. We've got the name resolution going here. I've got it going on here, and I've got it going on over here. Now, I'm not sure about this etsy host. I'll do a little bit of looking. I don't know if you could substitute the name here or not. Maybe not. Maybe you can. I don't know. But the thing that I missed was doing a secure copy from this recently compiled file, hello MPI. So what we do is we do a secure copy of hello underscore MPI. Now this is not the C file. This is the actual executable. And we're going to copy that to bill at 192.168.1.3 is compute node 1. Boom. And I'll do a 4, and that's compute node 2. And then let's try rerunning these things. So I'll hit my up arrow to get everything back. I did quite a bit of little looking here just to see what's going on, to see if I could figure out what's happening here. Here's the compilation right there. Boom. and then let's run it. I'll hit my up arrow some more to get the run command right here, there. Let's see what we get. Well, it's still delivering this 2, 3, 4, 5, so I've got a little more troubleshooting to do. Tell you what I'm going to do. I'm going to try modifying MPI hosts so that I have the name in there instead of the IP address. So the way that I'll do that is I will do a nano MPI tac hosts and hit enter. And instead of .2 here, I'll put master node. We'll see if it barfs. And then I will put compute node 1 here. And I will get rid of this, and I'll put compute node 2. And control O, enter, control X. Let's rerun this file. Yeah, and it's still giving me this 2, 3, 4, 5. So that bears a little more investigation. We'll go on from here because I want to do a little bit more programming. So what I did, since I essentially have a template here with hello MPI, I'll list this out. I made a duplicate of it. So I said, well, I want to move hello MPI .c to MPI template.c. So I typed in MPI template.c, and that made this copy. So I've got a template out there. Now what I can do is when I get ready to make a new program, I can just make a copy of MPI template, and I've got the basics filled in. Let me show you what MPI template looks like. So I'll nano MPI underscore template.c and hit enter. I've added one comment here, and by the way, I will copy this code and paste it into the remarks on the movie here about this word int at the start of the program. And then I haven't done any other changes here. It's really bare bones, so that's actually really good. And when you get ready to use the template program, you don't need to keep the comments. You could get rid of them if you'd like. So now what I want to do is I want to copy this, and this is going to be called ping pong. So I'm going to copy cp mpi template.c to mpi underscore ping pong.c and hit enter. ls, did it make it? Yep, there it is. So now I want to nano mpi ping-pong.c, and I get all this stuff, and I don't need all that. So I'll get rid of these comments here. Very quick and dirty. Like that. So now I want to show you what would happen if I save this, and I want to open it up in LibreOffice so you can see that, because that's actually a really good way to edit this stuff. So I'll do a Control O, click an insertion point here, Control O and enter, Control X. I'll open up the Debian file system here, go to Bill, and let's see if we can find that. Here's ping pong, so I'll double click that. Now this is opening up LibreOffice. This is included with Debian 12. LibreOffice is an open source office computing program that's quite good. I like it a great deal. If you wanted to save this off, for example, as a Word document to send to somebody that's using Microsoft Office, you just do File, Save As right here, and you could tell it that you had a different type of document that you wanted to save, and it will do it just fine. Like here's text. There's the other choices you have here. So it's actually really, really cool. Supports Word. I like that a lot. But anyway, I'm only interested in this because this is a little bit easier way to get at it so that you can see what I'm doing here. Okay, so now we still include mpi.h. In fact, let me take and highlight this code here. Make it a little bit bigger so that you can see it. I like the color coding. There we go. I like the color coding when I'm working with Nano, but I like being able to show it to you as well. So it's kind of a hit or miss thing. And this should be, say, stdio.h. I accidentally erased that earlier. Got the same old function stuff here. World size, world rank. None of this changes. Now what we're going to do is create a brand new variable, and this variable is going to be, everything we do now is going to be above MPI finalize. In fact, I think this may be a little too large. Okay, I copied the code in and fiddled with it a little bit so that it looked a little bit better. I want to show this code to you. So the code starts right here. Everything up here is part of the template that we copied in from before. Here's where we start the ping pong code. So we create a variable called ping pong count. The way that I would phrase this is that it is of data type integer, so it's expecting an integer. An integer is a number that does not have a decimal point and decimal numbers following it. So it's just a plain number, it can be negative, 0, or positive. And the other thing you need to know about integers is that if you try to pass a number in that has a decimal value, it's going to be truncated down to the integer. So there is an issue there. Now this is saying that we are declaring and initializing a variable. So let me put a comment in here. Declare and initialize a variable. Now it's very common to see programmers declare a variable and then not initialize it until later. So they'll say int ping pong count semicolon. Then later on down the line they'll say ping pong count equals 0. So that's setting ping pong count equal to 0. Here we're doing everything in one fell swoop. And it's common to do both. Either way works. We also declare a variable here called partner rank. I'm going to put a space in here so you can see it. Partner rank is going to be world rank plus 1, and we're doing a modulus operator here. Now what does the modulus operator do? It is returning the remainder of a division operation. So we take a world rank, let's say the world rank is 1, and then we divide it by the world size, we get some number, and then we take the remainder of that number, and that's what the modulus operator it is. This is very, very common in coding. I'll point this out here for you so that you can research the modulus operator. It's used extensively in programming. It's a very useful tool. You should know more about the modulus. Then we set up what is called a for loop. Now this is where you have to start paying attention to semicolons or curly braces and semicolons. So a for loop is in C. This looks very, very common in C, C++. The way that it works is you're saying, I'm going to start a for loop, and what I wanted to do is I wanted to iterate through. I'm declaring an integer called I, and I'm initializing it to 0. Then I put in a semicolon. So essentially, this is all one C statement right here. But then we go on and we tell the for loop, I want you to go as long as I is less than 10. And I have another semicolon there. And what that will do is it'll iterate through this loop X amount of times until it gets to the number 9. Now we said less than. There is a declaration where you can say less than or equal to. But it's very common to see less than 10 or whatever number you want to go less than. And then we finally do an I++. Now what this does is this takes I, and as soon as the loop is done running the first time, it updates I to the next number. So it starts out at 0, then the loop runs, and then we do I++. So now I is 1, we run the loop. I2, we run the loop until we get clear through and we're done with I9. Then it evaluates and says, oh, I'm not less than 10 anymore, and it drops out of the loop. So that's what the for loop is doing. Now what you've got to do is you've got to get in the habit of really looking at where these curlies are at. If you're using a common IDE like Visual Studio Code or something like that, you can what you can do is you can highlight one of the curlies and it will designate where the ending curly is at. But in this case, I think that the ending curly is probably here. We'll see if we get in trouble with that. Now we're saying if world rank equal. So what this is saying is it true? So equal means is it true? Means is it true? So we're saying if the world rank is equal to I modulus world size, just like this. If that's the case, we're going to increment ping pong counter, and we're going to send ping pong counter at 1. We're going to do a mpi integer, partner rank 0, mpi com world. So there's a ton of stuff that we're sending into this mpi send function. I'll go over the details of that in a later movie because I want you to understand what it's doing. Then we print out what we did, just like before. But if world rank is equal to partner rank, then we send a different message, and we say that we received this. Finally, we do an MPI barrier, which is going to synchronize all processes and finalize. And I think I've got this thing indented too far. And what I like to do is I get in a habit of making sure that everything is closed in. So here's the else if. It starts here, and I close it here. And here is the if, let's see, if blah, 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 right here. And it terminates right here. So I should probably move that over just so it's easier to see, like that. And then we have the for loop. So the for loop starts here. So if this was confusing to me, what I would do then is I would take and bring this in maybe a couple, just so it would be easy for me to see what's going on here, like that. And I might move this in a couple, so it's easy to see where things are at and how they end. So now I have my if, and here's the end of my if, my else, here's the end of my else, and this is the end of the for loop right here, and right here, and then finally I call MPI finalize and return 0. So that all looks good. So what I'm doing, I'm using LibreOffice to do this, so I'll just hit the save button like that. Use text format, that's fine, and close this. Now that we've used LibreOffice, what we want to do is we want to check and make sure. So I'm going to cat MPI pingpong.c and make sure that it came out the way I wanted it to. And it looks okay. Everything looks fine here. It looks like it took it all. And what I have to do now is I have to copy this over to the other nodes. So I'll close the screen, and I'll do an SCP. Let's see, I want to get the name of the file correctly. I'll do a screen copy, SCP mpi underscore pingpong.c to bill at, and you could use note names. The name resolution is working fine. The compute node 1, boom, beautiful, and compute node 2, beautiful. And then I'll hit my up arrow and we'll get the run command back again. Now instead of hello MPI in this case, what I want it to do is I want it to run MPI pingpong. We've copied it over to the other nodes. Oh, you know what? I haven't compiled it yet, so let me go ahead and get the compilation program first. There it is, MPI CC. I'm going to compile MPI pingpong.c, MPI underscore pingpong.c to MPI pingpong. And then I'll do that secure copy again because I copied the wrong thing. So I'll take the .c off of here, like that, and hit enter. And I will do it one more time to compute node 2. And then let's execute this thing and see if it's going to work. So MPI CC, and we want MPI run is what we're looking for. It's up here a ways. There we go. And now we want to say that we want to run MPI pingpong. Like that. And number of MPI hosts is fine. Number of processors is 6. That's fine. In fact, it might take a little bit of time for this to run, so I'm going to run it down to just 2 processes in this case. Let's see if it flies. Beautiful. That looks really good. So you can see why it's called ping pong, because it's ping-ponging back and forth here. So that works really well. Okay, now what I'll do is I'm going to go through and do a couple of troubleshooting techniques. I want to explain to you the function that it's using there, because that is a pretty complicated little function. I want to also talk to you about the resolution of host names so that you can see which one it's hitting, what it's doing. But I'm going to save that for the next movie because you're going to wind up doing quite a little bit of troubleshooting when you're working with something like MPI. So we need to know how to dig in there and how to find out what it's doing. And you probably need to know about the OpenMPI API, because that'll help you figure out what the functions are looking for and what they require. But the movie's gone pretty long, so in this case what I want to do is say adios, and I will see you in the next video. Thanks for listening to these videos. I really appreciate you guys subscribing, telling your friends about it, listening to the video, leaving comments. It's all very good stuff. Really appreciate it, and I hope you have a great day, and I will see you in the next video. Take care.